This is a short tutorial for grabbing data from a graph that has been stored as a JPEG, and we're going to use the Data Digitizer software that you have obtained. It should be located in a folder, and just go use MATLAB to go to this folder, and then make sure you cleared your workspace, and then type Data Digitizer. Hit the Tab key if you like to find out what versions you have. That's version 2. We'll just go ahead and start it up. And a figure shows up, and what we want to do is we want to first load in that image, which has our graph that we want to obtain our points from. So click on Load Image, and I've already got some images captured in here, so we're going to go ahead for demonstration and use this one. And this is a graph of wave 5 latencies for the auditory brainstem responses as a function of age in months. So we're going to go ahead and capture this data. First thing we need to do is we need to set a bounding box so we know the limits of the graph here. And so I'm going to go ahead and select box. The first thing we need to do is set the bottom corner. And because this doesn't start at 0, I'm going to set the bottom corner here at 8 milliseconds for the wave 5 latency and 0 for the corrected age. And then we'll go over to the next, which is to get the extent of the x-axis. I'm not going to go all the way over to adult because you'll see those two broken lines down here. This isn't a continuous function, so I'm just going to go to 18 months and select that point there. And then the final third point is selecting the top of the y-axis. And again, I don't know what this is. It's probably 15, but we can just select this here as 14. And that's going to set our x-y scaling for the graph. And so that will draw a box. So that now sets our scaling. The next thing we need to do is label our axes. So the y-axis, we'll call it wave 5 latency, and that's in milliseconds. And our box that we just drew in red, we need to set the limits to that so we get the proper correction scaling. It goes from 8 to 14 milliseconds. Okay, so we've set that. And then we also have to do the same for the x-axis. So it goes from 0 months to 18 months. So we'll set that at 18 over here. And then call this axis corrected age in months. Okay, so now we've got our box set. So that we'll put the proper scaling. So then when we go and select each one of these points, it'll read out the correct values in latency and corrected age. So we need to go and select these points, but we need to say what condition it is. So we have 3 different conditions: 500 Hertz, 2000 Hertz, and 4000 Hertz tones. So our first condition will be 500 Hertz. We'll say new condition. And then we'll add another condition. Now this is a menu box. Currently there's only one item selected, but we'll go new condition. And now you see that there are 2 items in there, 2 conditions. And then our third condition, 4000 Hertz. We're going to first get the data for the 500 Hertz. And we're going to go and get the mean data. So these are the square boxes are the means for this data. And these lines down here are the standard deviations. But first we'll just get the mean data. You can go ahead and click and try to get it as close as possible to the middle. After you've done this, you can actually click and drag them around. So you click with the left click to put the data point wherever you think it is best. Okay, and you can move it around. Let's say that we think that's the best. Then you do a right click to store it. Okay, so left click to select, right click to store it, and now it goes on to the next sample, and left click to set it, and we can move that around again. Let's try to get it right in the middle there. And then right click to set it. Okay, so now it's set, and now we're on to the next one. Okay, left click, right click to set. Left click to select. That's not quite right. I'll say that's good enough. Right click to select, or sorry, to set it. And then left click to select, right click to set. And when you're done, hit the escape key. That will stop the data digitizer. Okay, so now we actually have the data, and you'll see that this button came up that you can actually save the data if you like, but we're going to go on and collect some more. Now, if we're not quite happy with maybe this marker here, we can actually go and click and we can drag it to wherever we think it might be. Okay, so we can make little subtle changes to it at the end. So maybe that's a little bit better. Maybe that one's a little off. We want to get that selected a little bit more accurate. And it's a little bit finicky. That's just the way that you actually, as the user, are using it, moving a mouse. So you might be able to use a pen digitizer to make this a little bit better. Okay, so now we've selected the means. We can then go get the standard deviations for that condition. So make sure you're on that 500 Hertz and go, and it's the same thing, but the other markers will be a little bit different. They're crosshairs for the standard deviation. So left click to select, right click to set. So left click to select, right click to set it. And again, we can also, after the fact, move these things around. So just get them, I found it's easiest just to get them as close as possible and then move it around after. And the last one, left click to select. That one, see, that one didn't save. If you hit the right click a little too fast after you've set it, it doesn't register it. So now that's registered, and then we'll do our final one here, and then right click. And now hit escape. So now that's stored in there, and we can move these things around a touch if we want. So maybe that one is a little bit slightly off there. Now what you can see is that when you select any of these and move them around, it'll actually give you at the top here what sample you're selecting. So this is 1, 2, 3, 4th sample, and it gives you your X. So this is 12.9 right now, months by 11 milliseconds there. So it will move and tell you what your actual values are. So let's say that's good enough. We can then go ahead and save this data. So we can go ahead and set save. And for this, I'll just save it over top, Wave5 latency maturation pediatric. Okay, so we'll hit save, hit replace, and it's always good to save it just in case something crashes, and then we can go on and collect the second condition, which is 2000 Hertz. And again, go ahead and select these points, left click to select, right click to set. Okay, and we can go ahead and do that for the third condition. Now you can also go ahead and delete these if we wanted to. We said, you know what, we don't want that condition. We can go ahead and delete the condition. The other thing I wanted to demonstrate that is if you do select the mean data again for this condition for 2000, it will erase what you already have here. So I'll just demonstrate that. So it erased those points, and then you're going to have to go in and replot them again or reselect them again. Okay, so just note that you can't go in after the fact and add more. You have to go through it all again. Maybe in version 3 we'll update that so you can go and add more points after the fact. But currently it's set that you have a one-time selection process, and then when you hit escape, you're done. But you can still go after the fact and move them around. Okay, then when you're all done, go ahead and save that. Show you how to then get that data in MATLAB. So let's just save that there, hit yes, and we can go ahead and close this. Okay, so that data was saved in this Wave5 maturation, and we can just simply, we see that there's nothing in our workspace, and we go ahead and we load this data, and it will actually load up the entire image again, in which you see here. So all this data is there. It also loaded a variable called handles in your workspace. So if you look at this, handles has all the information that was stored in that actual figure. Now note, when you load this data back in, you will not be able to go through the functions because it's not associated with a program. But all the data is there and you can re-visualize it. But what you are looking for is this handles data structure. Okay, so now that there are 3 conditions and it has name, data points, standard deviation points, that's the data along the x-axis, and y data, that's the data along the y-axis. So these are the x points, 0.5, 4, 9, 13, and 18. Okay, so we have labeling here 0.5 months, 4, 8, 13, 13, and 18. Okay, months. And then we also note we have here, these are the data points for the y-axis. Okay, so the data points for the y-axis there. And then we can just do that for each condition. So that's how we can extract the data for all of our samples that we digitized in this program. And then we can do other plottings as well as offline analysis and other statistics if you like. So that brings us to the end of this tutorial on how to use the data digitizer to digitize your samples of an image that you've collected from the literature.